Before starting to draw the scalar diagram, we have to, in the previous grade, we used bearing and distances to indicate the position of a point in a horizontal plane. We are only talking about one dimension, horizontal plane. In this lesson, we are going to identify the same thing, how to find a position of a point in a vertical plane. Horizontal plane means, horizontal means in a ground, okay, in a ground or in a road. What are the things located here and here and here? Here is our bank, here is our temple, here is our school. So what's the direction between these and what's the distance between these? Those are the things we've studied in our previous grades. Today we are going to study in the vertical plane. Okay. In the vertical plane, there are two key terms. First one is angle of elevation. Angle of elevation. That means this is my ground surface. Okay, here there is a tree and here there is a building. Lighthouse. This is me. No, this is you. Think. You can observe. Okay, you cannot observe the top of the lighthouse by your eyes directly. So here we are using a term called as angle of elevation. While walking, we can't observe the top of a lighthouse. To observe that, you have to bend your neck a little bit to observe that. So that bending will create an angle. That angle is called as angle of elevation. Okay, to observe the top of the lighthouse, what you have to do? You have to bend your neck, and if this is your eyes, from that eyes you have to observe top of this lighthouse. So in normal scenarios, while walking, we are not looking at the top and walking. No, in the eye line we are. Okay, in the eye line, this is the most preferential walking path of ourselves. We want to preferentially look at another object, we can bend our neck in above or below according to our needs. So to observe the top of our lighthouse, this would be the way you have to look. Usually your eye line, if you are standing like this, your eye line, okay, your eye line would be a horizontal line. Eye line would be a horizontal line. According to your height, a person who has 6 feet height, his eye line is little bit above. If you are 4 feet, your eye line would be like this. But definitely our eye line is, okay, eye line. This is called as eye line. Our eye line is the reference line we have to use while measuring angle of elevation. Usually, while walking, we are maintaining our eye line in a horizontal plane. Okay, this is a horizontal line. So this would be the way. To observe a preferential object, we have to bend our neck little bit above to observe that one. So what is the angle which is elevated from our eye line? That is called as angle of elevation. To observe this object, you have to increase your the vision little bit above. So this angle, okay, I will mark this angle as alpha. This angle alpha is called as angle of elevation. It's so simple. Okay. Usually we are doing that in mathematical terms. We are defining that one as angle of elevation. An angle of elevation is defined as the angle formed between the line of vision and eye line as an observer when the observer is looking at an object above the eye level. So when you are observing something located above your eye level, this is your eye line and this is called as line of vision. Okay, this orange color line, through this line only you are observing that particular top of our lighthouse. This is called as line of vision. Line of vision. And one important thing, a particular person. For a particular person, according to the object to object, when the object is changing, line of vision might change, but their eye line is always a horizontal line. If your height is 4 feet, your eye line, it is a constant one. Okay, always your eye line is same. We are using dotted line to indicate the eye line of a particular person. Now, another term we have, when you are observing something on the top, that is angle of elevation. Same thing, just think about it. This is a horizontal plane. A dog is here. Okay, a small dog is here. No, this is not a dog. This is a turtle. There is a small turtle. You are walking along the road. So now you have to observe this. Okay, you have to see this particular turtle. Your eye line doesn't change. Always you have to keep your eye line as constant. Okay, that is a must. In scalar diagram, definitely you have to indicate your eye line. But since this object is small in height, to observe that your eye line would be same. The line of vision, look at this. Eye line is same. That is in the horizontal manner. So what is the angle which is below your eye line? Okay, below your eye line. Since the object is small in height, we can't observe that one directly. So you have to decrease your eye observation vision line. So it would be like this. I will mark this angle as beta. These are some example angles. This is called as angle of depression. So here what's happening? An angle of depression is defined as the angle formed between the line of vision and the eye level, that is a horizontal level, okay, of an observer when the observer is looking at an object below the eye level. So when you're observing something below your eye level, you have to decrease your vision line, okay, sorry, the angle, and observe that particular object in that the angle which is beneath your eye line, that's called as angle of depression. Here this would be our line of vision. Above the eye line angle, angle of elevation. Below the eye line angle, that's called as angle of depression. But you must consider the eye line. That is the constant thing. From that only we can measure whether it's angle of elevation or depression. Mostly students are just, if there is a building, okay, think about it, you are on top of a building, you are just observing a small car which is parked in the road. To observe that, how to draw the eye line and everything? First of all, before drawing the line of vision, you have to measure what would be the eye line. This would be your eye line. From this eye line, you are looking below. So this would be the angle of depression in this case. Without having eye line, how can we define? That would be the angle and this would be the angle. There is no any other reference line. No. So that's why we are using eye line as a reference datum. From that you should measure. Actually, we are using clinometer. Clinometer, that is something like this. Okay, here there should be a straw. It is considered as a horizontal level, and below that you have to keep your protractor. And here in the thread that is suspended with a small nut or small steel objects, okay, so that means it has to be perfect vertical one and this is horizontal one. By using that, if you are measuring something, that means if your eye line is increasing, just look at this, your eye line is increasing, this will go something like this. In that case, the thread which is suspended with a metallic object, that will stay like this. Okay, it won't change because it has a small stone. Just think, this is a stone. You're just binding a stone with a thread and keeping that one in the middle of your straw, so it won't change. So the position, the vertical plane, that won't change. By using that, you can measure. This would be the angle of elevation. Angle of elevation. In the practical, we can do that one. And if you want to measure angle of depression, that also same thing. You can measure like this. Here it would be something like this. This one. Okay. When you are keeping some object in the vertical plane, in the bottom we have a weight, okay, mass. So that won't change, no, it has a mass. So other things, the straw and the position of the protractor, everything change, but this thread and this rock piece or the bolt nut, its position won't change. So this would be the angle of depression. Likewise, we can measure. Usually the people who are working in ships, okay, who are working in ships, to identify the location of the lighthouse, even though they can observe the light of the lighthouse that is always rotating. You are coming at here while observing this one from the measurement. Okay, here some person, they have an electronic device. By using that one, they can measure what's the distance between that particular boat to the lighthouse. There are some digital meters. By using that, directly they can see what's the distance we have to cover more to reach the lighthouse. So this is the common practice where we are using clinometer kind of devices. This is the common one. In other applications also, in aviations, and the people who are walking, okay, while walking they are